Alright, let's get started. So, this very first question, it's pretty clear that y'all didn't get it. So well, one person got it, Chase. Chase did a good job. Good job, Chase. So what is the ampacity of a 1-gauge THW copper conductor installed on a raceway located in an ambient temperature of 55 degrees Celsius? Well, first, you're going to open your code book and go to table 31015B16. That's what I have on the screen right now. So the question is asking for a 1-gauge THW copper conductor. So along the top here, you have copper, 3 copper columns, and 3 aluminum columns. And you can see the different types of insulation on these columns. THW is a 75 degrees Celsius conductor. So you'll be looking in this column right here. Now you're going to come down to 1-aught, or 1 gauge. 1-aught is one size up. So number 1, copper, you're going to come over and you are looking at 130 degrees, or amps. 130 amps is your starting amperage. So let's write that down. $130 amps. Next, you're going to flip back a couple pages in your code book and look at table 31015B2A. In this table, remember we saw it was a 75 degree Celsius conductor. You're going to come down to the 55 degree ambient temperature, and you'll have a multiplier of 0.67. If you read the title, this is for temperatures other than 30 degrees Celsius, multiply the allowable ampacities in the ampacity table. So 55 degrees Celsius is 0.67. So that's times 0.67. That's going to give us 87.1 amps. The question asks you to round to the nearest amp. So, went to the wrong, we're here. So, 87 amps is your answer. So just Chase. Alright, a conductor's allowable ampacity is directly related to the type of insulation used on the conductor. If you look on this chart, it is like a number 8 has 3 different amperages based on the insulation type. So yes, that is true. Alright, table 31015B16 can be used when there are not more than blank single insulated current carrying conductors installed in a raceway. That is 3. If you look, and I'm sorry, let me see if I can, I can't. I was going to try to get a better picture of this table. If you read the title of this table, probably easier to flip to it in your code book. But 31015B16 is for not more than 3 current carrying conductors in a raceway cable or direct buried, based on an ambient temperature of 30 degrees Celsius. So that is what this table is about. There is a 31015B I want to say 17. It's on the very next page, and that's for open air conductors. It is 17. 17 is for open air conductors. All the same stuff, but it's for open air conductors. We'll get to that in a couple questions. Temper correction table. The temper correction table 310.15b2a, which is what we were looking at a second ago, indicates as the temperature increases, the ampacity of the conductor increases. That is false. As temperature increases, the ampacity decreases because it becomes more resistive. And it's going to heat up more. The insulation will be able to withstand less amperage. Yes. So the ampacity on 310.15b17 is going to be higher than on B16 because in free air there's easier for airflow to pass around the conductor. So it's like 2 gauge THW copper conductor star Raceway ambient temperature 30 degrees Celsius have less ampacity. That's basically the same question. In a Raceway, you will have less ampacity than in just free air. Okay, 3 conductors in a Raceway, so that's 310.15b16. Oh wait, it's FEP insulation. So they direct you to 310.15b18. So 310.15b18 is still based. Oh, it is based off of 40 degrees Celsius. So you'll have to go to a different ampacity chart or modifier chart. So I'm just going to use my book. Use your book. I don't have the chart pulled up. The question was number 10 FEP. Number 10 FEP is 60 degrees Celsius. So we got 60 amps. I don't know why I keep getting that messed up. And then you'll flip to the important part is that this is a 40 degrees Celsius base on the chart. So you'll turn to 310.15b2b. Again, that's 15 B2B. And we're going for 60. I think it said 60 degrees. Maybe that's where I messed up. Yeah, it's 60 degrees Celsius. So we're going to look at that chart for 60 degrees Celsius. I believe this was a 75 degree wire. FEP is 200 degrees Celsius. So let's go all the way over to 200 degrees Celsius at 60 degrees. It's a 0.94. So it's 0.94. So you'll come down. Let's pull up our 56.4. So it'd be 56 amps should be the answer here. Looks like some people got it. Good job. Size 12 aluminum conductors within a UF cable are generally considered to have the same allowable ampacity as size 12 aluminum single conductors marked with the NEC insulation type of. That will be TW. If you look on this chart, it says UF and TW in the same 60-degree column. In your book, I would recommend write Romex also, like right across here, so that you know, and then write wet locations right here on your copy of the book. Of course, I'm about to give you a brand new one next year, in third year, so TW. Temperature rating of THWN. Well, that's again, look at this chart. THWN is 75 degrees. Temperature rating of THWN-2. All of the -2s are 90 degrees Celsius. Branch circuit is defined. This is Article 100. You look up branch circuit and you got it. A feeder is defined in the NEC as all circuit conductors between the service equipment, the source of a separately derived system, or other power supply source, and the final branch circuit over current device. Again, it's definition. Article 100, just look it up. So, again, it's a definition, Article 100. Shouldn't be any issue there. Okay, this is talking about the rating of a branch circuit. We're going to look in 210. All of the branch circuit articles, or Article 210 is the article on branch circuits. So all of your requirements for branch circuits will be in 210. And this is 210.18 is talking about ratings of branch circuits. And the basic rule of thumb is the weakest link is what the circuit is rated. And the circuit breaker needs to be rated for the weakest link. And if you put a 20 amp breaker, that's basically setting the rating of the branch circuit. Even though you put number 10 wire, that's not for amperage, that was for voltage drop. So our amperage on the rating on the circuit is 20 amps. Each multi-wire branch circuit shall be provided with the means. Okay, so a multi-wire branch circuit, what you would look up is branch circuits, then multi-wire in the index. And that will send you to pretty close to the front. 210.4 is where that will send you. 210.4b talks about disconnecting means. Basically, if you share a... So, that's a good question, Corey. I will circle back to that after I finish this. Each multi-wire branch circuit shall be provided with means which will simultaneously disconnect all ungrounded... Oh, sorry about that. My vacuum is starting. Okay, simultaneously disconnect all ungrounded conductors at the point where the branch circuit originates. If you share a neutral on a circuit, you have to turn off all of the shared hots at the same time. whenever you're sharing a neutral. So you have to put like a 220 volt or like a 2-pole breaker in the breaker box so that you shut everything off at the same time. Okay, Corey asks, I thought it was only 80% of the breaker. That is a good question. If you flip back to part 2, branch circuit ratings, branch circuits recognized by this article shall be rated in accordance to the maximum permitted ampere rating or setting of the overcurrent device. So where conductors of higher ampacity are used for any reason, the ampere rating or setting of the specified overcurrent device shall determine the circuit rating. I think it's a matter of semantics. You can't put more than 80% on that breaker, but a circuit rated for 20 amps should only have 16 amps on it. You do 80% of the circuit's rating, which is generally set by the breaker. Okay, and we just talked about this one. Branch circuit voltage for luminaires in a dwelling unit is limited to blank nominal between conductors. That is 120 volts nominal. This one is voltage. Flip back one page. Branch circuit voltage limitations. That is 210.6. You would look up in the index branch circuits and then voltage limitations. Should take you right here. And then you would look through there. Basically, the intent behind this is so that you don't have high voltage available at something that an end user is going to interact with often by changing light bulbs. There can be open conductors where the user can get to them. And that's really the only spot in a house where a person can access the conductors is light sockets. Which of the following commercial locations? So, branch circuits and GFCI protection. Ground fault so 210.8 is ground fault circuit interrupter protection for personnel. That would be under branch circuits, then ground fault protection. You can see dwelling units and then other than dwelling units. Other than dwelling units is the umbrella that catches everything else. And it lists all the places that do require GFCI protection. I do not believe it lists any places that do not require GFCI protection. So you would just read between the lines and, well, bathrooms, indoor wet locations, kitchens, and rooftops require GFCI protection. It must be finished portions of a basement. And I think it actually says unfinished portions of basements. Yeah. Unfinished portions are areas of basement not intended as habitable rooms. Basically, a basement needs GFI protection unless you like finish it out like it's going to be a whole part of the house. Basically the same question, and it's finished basements again. Grounded conductor of a branch circuit is most commonly identified. So if you flip back to Article 200, that is the grounded conductors or neutral article. The neutral should be white or gray. It's one of the few conductors that it's like they say, hey, it has to be these colors. Hot conductors can generally be any color. Like your ungrounded conductors can generally be any color that you want. There's very few rules about them. So yeah. Next up. Receptacles rated 15 amps are permitted to be installed on both 15 and 20 amp branch circuits. That is true. I don't remember where I found that. I don't think that's in the receptacles section. I think it's in actually the branch circuits. Branch circuit ratings. Oh, receptacle ratings. Where connected to branch circuits supplying two. No, no, that's not it. 15 and 20 amp branch circuits. This is 210.23 A. Nope, nope, that's not it. I apologize. I don't know where that is in the code book. Uh, Suffice to say that 15 amp receptacles and 20 amp receptacles are different. Their faceplates are different. The blades on a 15 amp receptacle are like this, and then on a 20 amp receptacle, let me pull up the drawer. So the blades on a 15 amp receptacle are like this, and then a 20 amp receptacle, they are like this. Because a 15 amp plug, or a 20 amp plug, the blades on it are like this. So you can hook up a 15 amp receptacle because things that draw more than 15 amps don't have a plug that could plug into it. So you can't draw more than, things are just designed so that you can't draw more than what you would need. It would not work the opposite direction where you are allowed to install 20 amp receptacles on a 15 amp branch circuit. I do not believe, because it would just trip the breaker. It bothers me that I can't find that today. Okay. What is the maximum load in amps permitted to be cord and plug connected to a 20 amp multi-outlet branch circuit? So if you look at 210.21B2, there's a chart that you will look at. It's basically the 80% that Corey was talking about. 20 amps on that chart is... I have 4 risk for my online security. Oh no. And this same question, same chart. That's table 210.21B2. A multi-wire branch circuit for an individual piece of utilization equipment supplies a line to neutral load. Oh, acceptable. Okay. This should be acceptable. I believe the rule is that is required to. It can only supply line to neutral loads. You can't have a multi-wire branch circuit and have 120 volt things and 220 volt things, or 240 volt things on that same multi-wire branch circuit. So that one is 210.4, and it's in the exception. Uh, in dwelling units, the voltage between conductors that supply luminaires shall not exceed 120 volts. So we already kind of covered that one. Okay, so there is an actual section on AC equipment, branch circuits, and if you flip, it's in the required receptacles. So it's under part 3, required outlets, and heating, air conditioning, and refrigeration equipment. So if you look up branch circuits and uh, heating, air conditioning, and refrigeration equipment, it tells you that you have to have one within 25, a receptacle within 25 feet of any heating, yada yada yada. This is a courtesy receptacle so that people who work on that stuff don't have to stretch cords out from BFE. Uh, Hallways and dwelling units must have a receptacle outlet if the length. So, and this is required receptacles again. It's for hallways. If you just look up required receptacles, hallways, branch circuits, hallways, it is, did I just put it? Yeah, 210.52H. And it just spells it out right there, 10 foot. So that's 210.52H. Receptacles mounted in or on floors located within 18 inches of a bedroom wall in a dwelling unit are permitted to be counted as the receptacle outlets required by 210.52. That is true. You can, if you have a floor receptacle within 18 inches of the wall, one, why would you do that? Why would you put a floor receptacle that close? Floor receptacles are so much more work. But if you did, it can count as your required receptacles. The whole point of required receptacles is that people can plug things in. Things generally have a 6-foot cord, and people would be able to plug things in anywhere along the wall, or set things up anywhere and plug it into the wall without having to, like, well, I don't have a plug to plug it in here, so I have to, choose a spot. So this is back to that same page as the AC refrigeration. You will, electrical service areas, it'll have that requirement. It's 25 foot from the thing. So that was a 30-minute stream to get 28 questions. Sorry that lasted a little bit longer than normal. Like always, send me questions if you've got any. These videos go up whenever I finish, so you can rewatch them, put them in slow motion, put them in fast, whatever you like. So I'm going to wrap up here and put up the next quiz. And lunch will happen over the course of this quiz, so you guys can, I think I allocate like an hour. Y'all have like 3 hours to get this quiz done. All right.